GCSE Physics, the generator effect, smart path tutoring. Cutting field lines induces a potential difference. The more field lines that are cut by a moving wire, the greater the rate at which the wire cuts through the field is moving relative to a magnetic field. The generator effect creates a potential difference in a conducting wire and a current if the conductor is just part of a complete circuit. You can do this by moving a magnet in a coil of wire or moving a conductor wire in a magnetic field. Cutting magnetic field lines. Shifting the magnet from side to side creates a little blip of current if the conductor is part of a complete circuit. If you move the magnet or conductor in the opposite direction, this creates the reverse current while it reverses. Likewise, if the polarity of the magnetic field is reversed, the magnetic field reverses. You get the same effect or the coil moving backwards and forwards. You produce a potential difference that keeps swapping direction and alternating currents. You can change the size of the effect by shifting a magnet and coil in relation to each other's inside a magnetic field. As you turn the magnetic field through the coil changes. This change in the magnetic field induces a potential difference, which can make a current flow in the wire. When you turn the magnet through half a turn, the direction of the magnetic field through the coil reverses. When this happens, the potential difference reverses, so the current flows in the opposite direction around the coil of wire. If you keep turning the magnet in the same direction, then the potential difference will keep on reversing backwards and forwards, and you'll get an alternating current. Induced current opposes the change that made it. So a change in magnetic field can induce a current in a wire, but as you saw, when a current flows through a wire, a magnetic field is created around the wire. Yet, that's a second magnetic field. Difficult to tell the two between whose field lines were being cut in the first place. The magnetic field created by an induced current always acts against the change that made it, whether that's the movement of a wire or a change in the field itself. Basically, it's trying to return things to the way they were. This means that the induced current always opposes the change that made it. You can change the size of the induced potential differences. If you want to change the size of the induced PD, you have to change the size of the magnetic field is changing induced potential difference, and so induced current can be increased by either increasing the speed of the relative motion between the magnetic field lines and a given wire, increasing the strength of the magnetic field so there are more field lines that can be cut. Thank you for watching. Please don't forget to subscribe and like the video.